by welcoming you, everyone for this morning session. I'm Juan. I'm going to be the chair of the next two sessions. I'm very excited about it because there are topics that are very interesting, and I still had planned to attend these two talks. So the first talk would be given by Daniël Willemsen Welmoet, and they're coming from GoData-driven and Vault.com, and they're going to talk about Streamlit dashboard and applications into machine learning and production. That's very, very exciting. So please give them a round of applause. So before giving you the stage, please remember to turn off your devices, ask questions through Slido, and please take pictures and tweet what's happening here. So the stage is all yours. Thank you very much.
Thank you very much. So welcome everyone. Let me start off by saying that this title is actually a little bit of a clickbait title, because the title says how a simple Streamlit dashboard will help you put your machine learning model in production. But actually, it's more of a story about how a Streamlit dashboard helped us put our machine learning model at Bol.com into production. And by sharing this story with you, we hope you can learn something from it as well. And maybe in the future, it might help you as well to put something in production. So let's start off with a quick question. Who of you have built some data-driven applications in Python, either machine learning or some other form of data science or data? Yeah. Basically, all of you, kind of what you expect at the PyData conference. Really nice. Then second question, who of you have struggled to get a model into production? Nice. Yeah, not nice, of course, but I'm very happy to see that, because then maybe this talk is useful. But I think before we can really answer this question, we need to define what do we actually mean with production. And I think there are two kinds of production that you can talk about. On one hand, you have a data science model that's deployed and running somewhere on some infrastructure, and it's accessible. And on the other hand, you can have a data science model that's actually being used by a user, and that's providing value to the company that it's in use for. And in this talk, we're talking about the second thing. So given that we have a model, given that it's running on some production-ready infrastructure and whatever, how can we actually get the user to be willing to use it? So, a very brief introduction to ourselves. Who are we and why are we actually talking?
Yeah.
I think Welmoet can start.
Good morning. Welmoet, I'm the product owner working at Bol.com. I will tell you later a bit more about this company. So I'm mainly focused, of course, on the value that we deliver. So that will be my part of this conversation.
Yeah, and my name is Daniel. I've been a machine learning engineer at GoData-driven for about a year now. And for the past 10 months, I've been working in Welmoet's team trying to get some models into production. So I think we are in the same boat as many of you have been or still are. We struggled to get our model in use, but in the end we managed, and that's what we want to share today.
Let's see how this works. That was the previous one, right?
That's the right one.
Oh. So I'd like to tell you a little bit about our company to get a little bit of a clue what is it actually the growth that we're working on. This is quite a complex picture, but the main takeaway is that we are an online store working in the Netherlands. Started already quite a while back in 1999, only selling books. But we started off as books online. Started off in a porta cabin, very, very small, so very entrepreneurial. And then in 2002, we took our own, weren't anymore connected to the books online worldwide. We started on our own, and we emerged with quite a lot of articles, and also went into Belgium. So we're now focusing on Belgium and the Netherlands. And just to get some of the figures, what we're talking about. So we are working in the Netherlands and Belgium, and I have to read the numbers as well. So there are 13 million customers that we're currently facing, and quite some visits a month, you can see, with a lot of products. We already grew up to 5 warehouses, still growing, and we deliver more than hundreds of thousands of parcels a day in the Netherlands and Belgium. Our main base is Utrecht, being part of Ahold Delhaize, and from the 2,400 employees now working at Bol, we're now working with 50 data scientists, and that number is also still growing. I'd like you to tell a bit more about what was the thing we were challenging. Well, over here we've got this customer ordering 3 articles. And of course, in the end, he's expecting a parcel at his house. But we have 5 warehouses. And then you get to a new challenge, at least a logistical one. Since not all articles are in the same warehouse, so they are scattered among different warehouses. And then, of course, you get the logistical question. Where do you sort which article and what do you put combined in one parcel that you will send to the customer? And we used to do that based on cost. We had 1 warehouse, then we had 2 that was quite overseeable. We created a model and looking at costs, what was the best combination. But then we saw sometimes that one of the warehouses was reaching its capacity. We had a solution to that as well. We took our controller, some people being in the office and trying to steer away from that warehouse and still managing to get all the parcels all right. But as I said already earlier, we're growing and growing. And the complexity is just getting too large to be overseeable by an employee. So this controller way of working was working, but not for the future anymore. And that's where data science came into place. We were asked to create a decision model to automatically balance between capacity and cost. So still cost, but also taking into account cost. So the team started up together with Daniel and a lot of other data scientists, worked very, very hard. We had this tight schedule because we wanted to be ready before October when our peak season starts. And we were so happy because we created this very nice working model right in time. But then we had the next challenge. We had this guy with his controller still in his hand saying, well, what do you think you give me? He was not happy at all. So we started some discussions, and we found out actually that we were giving him a black box. And he was still holding his controller and still wanting to be able to steer and to make sure our customers got our right parcel right in time. So that's where the question arises. Why didn't the customer want our model? So basically, it was our internal employee, but he wasn't happy at all. So Daniel.
Yeah, so we thought it was really interesting because this internal customer or the user of our product, he was actually they were the ones who rang the bell and asked us, hey, can you deliver us this model? We really need it, we really want it. But at the moment where we wanted to deliver it, then suddenly they put on the brakes and they said, yeah, no, not so sure about it. So what happened? And to try to explain it, at least from our experience, I want to go back a little bit to how we as data scientists tend to build a model and develop some applications. So this is a picture of a data scientist. If you Google data scientist, this is the first one you get. Super stereotypical, of course. Nice tie, shirt, always glasses. I think maybe he looks a little bit like me. And of course, all the fancy graphs that you as a data scientist never work with, but hey, still showing it. So yeah, that's our data scientist, right? And when we get put on an assignment, we start working. We basically often start with some data exploration. Hey, what is the data? What can we make of it? And then from this data, we get some nice insights. Maybe we can even develop a predictive model or something like that. And then in the end, not always, but very often what we want, and in this case as well, these insights, they influence certain actions. And the actions that we were influencing was what packages are going to what warehouse. And we hope that through our insights and through the actions that we're influencing, we end up providing some value to the company, right? In this case, We were reducing the capacity on some warehouses such that more packages could be sent again from them. And that way we could increase revenue at a little bit increased cost. But that would be well worth it. So as data scientists, we do all this nice analysis. We make some nice notebooks. And then we develop a model or even application in our case. And then we get the user. Of course, we already involve the user throughout the process. In this case, you can recognize the user by the fact that they're the ones actually doing the work. They're busy running the business. And then we get back to the user and we say, yeah, we have developed some things. We show them a very nice Jupyter notebook with all fancy graphs, maybe with PowerPoint even. And we show, hey, we tested our algorithm. It works perfectly, trust us. And then we give them the algorithm. And then we probably have a couple of meetings about it where we say, yes, it works. Look at this and this KPI. And then the next step is, of course, that's a machine learning model. Looks complicated. That's always how these things look. And then the next step is, of course, you get a really big fence. And you take your machine learning model and you try to throw it over the fence to the customer. And at least this is what we did. And if I look back at it now, yeah, surprise, surprise, the customer didn't really like it. Because we had these nice graphs, we showed them, hey, it all worked, right? Trust us, you see these graphs as well right now. And then we took them away, because they were still only in our presentation, only on our notebook. And then they just had to believe us. I think this slide is the most important slide of this presentation. And that is, a model entering use requires trust from the user. And that trust can be built up through continuously giving the users these insights that they need. Rather than only once giving them in a presentation or maybe during testing giving them. At the moment when a model enters use, when it's actually influencing their responsibilities because they're responsible for the business, then they should be able to see, hey, what's going on? As I said, the user is in the end responsible. So why don't we just show them what they're responsible for and show them how our model is influencing what they're doing? And then, of course, when we're discussing this, also with Welmoet, we have a mixed team of software engineers and data scientists and machine learning engineers. And the software engineers immediately thought, oh, we can make a very nice web app for this. JavaScript, Java, Kotlin, React, I don't know, whatever they all wanted to use. And on one hand, it's a super nice idea. But on the other hand, yeah, then suddenly it takes a lot of effort. And I think here where something like Streamlit can come in, you don't have to make it very difficult. It can be super easy to build a dashboard to show these insights. Because what we as data scientists have done when we were building up this pyramid, we've been using Jupyter notebooks. We've been coding all this stuff already in Python, usually for ourselves to see how well is our model doing. We've even showed them in a presentation to our users. And then if we have this Jupyter notebook, then we can fairly easily convert this Jupyter notebook into a nice dashboard with tools like Streamlit. And I think Streamlit is maybe just one example. I think Plotly Dash might also be one. I think there are more Python-based tools. But I do think what's super nice is that if you use a Python-based tool for it, because you already have the code in Jupyter Notebooks, and then it's just Control-C, Control-V, maybe writing some extra stuff behind it, but that's it. So who of you have already used Streamlit before? I'm curious. About half of you. Okay, so then maybe the next part will be a little bit basic for you. But I've been talking about how easy it is to do this and why you should do it. Basically my message for the last 2-3 minutes. So I've been preaching this, but I always heard practice what you preach. And we're at a PyConDE event. So I think it's better to just show you what we're doing. Live coding is always scary, so let's hope it works. Is this readable now? On the right side, I hear no no's, so that's probably a yes. All right, so what I have here on the right side is a very simplified version of one of the notebooks that we were using for evaluating our model. So we have some data that we load in this case order data from customers. And we see how our algorithm, our model, influences the decision to which warehouse it was sourced. Sometimes it was the same, sometimes it's different.
Yeah, now these are fake
Yes, of
numbers
course.
because we couldn't share the real numbers because we're currently in an IPO, so we're not allowed to share any numbers. But just for the idea, it's just the same.
Yeah, so we made up some fake data. Idea is still the same. And we can also load in some nice warehouse data. And then we can, of course, show this in a graph. Hey, during the day, how much orders are going to which warehouse? And if I'm looking at this graph, I see, in this case, a warehouse called PK. It's fairly busy, it appears, right? So if I'm now our user, I might expect, hey, that's not so nice. What's going on? Why is this warehouse so busy? Now, again, super simplified version. If we then look at a little bit more insights to it, maybe this could be a model predicting how busy is a warehouse going to be, or in this case, just very simple, what is the fill rate of a warehouse? So how much remaining capacity do we still have? And there we see that our peak warehouse is actually least filled. Okay, given these insights, what do we now expect our machine learning model to do? Well, we expect it to move packages away from BFC and Veerweg towards peak, because peak has the lowest, has still the most remaining capacity. Well, the way we steer it is through assigning penalties to these different warehouses. So we make a fake cost that we add to each warehouse, so that busy warehouses get a little bit more expensive in our algorithms, and very empty warehouses get a little bit cheaper. And that's exactly what we see here. We see peak warehouse during the day getting a negative penalty, which means packages are being steered away from this warehouse. And then finally, well, what are the consequences of the actions? How are the actions actually happening? In this case, we see indeed at our BFC warehouse, we have a negative item difference, which means packages are being steered away. And on peak, we have a positive item difference, which means packages are being sent to that warehouse. So indeed, our model is behaving as expected. And then the final step of this pyramid that I was talking about is the value. So how do these actions, how do they actually influence the value of our business? In this case, I have made up two KPIs. One is the cost per order. And in this case, we see, as we expect, the cost per order goes a little bit up because we're no longer purely steering based on cost. They're also steering based on capacity. In this case, it's about 3 cents per order. So I think that's doable, 4 cents. But what is the effect on the free capacity? So the lowest free capacity that we have on a certain warehouse. Well, originally, we would have gone over capacity. So there was going to be a warehouse that no longer could deliver its packages. With our steering method, we now achieved 500 packages that could still be sent from that warehouse. I think that's a really nice result. So this is something that we could show in a presentation to the user. But I would really like this for the user to see at any time, to just go to the dashboard and see this. So what I'm going to do right now is convert this notebook into a nice dashboard.
Yeah, that's how it actually started, because they were showing me, like, okay, Welmoet, we've got this, the model is working. And then I said, well, can't we show this to the users? Because if you already have it, well, come up with something and just send it over by email every hour. I don't care, just make it quick. I want to go live. So no fancy stuff, just do it.
Yeah, and in the end we actually found, like, rather than sending over the notebook every hour, that this was easier to do, so. Yeah.
I'm just a product owner, always looking for solutions.
So, okay, the first thing you do if you want to make a Streamlit dashboard, you import Streamlit. I think most people do it, import Streamlit as ST. And then you can basically do exactly the same thing as you do in your notebook. So when you execute your Streamlit script, or when you refresh the dashboard page, it basically just executes Python code. If we want, in this case, I'm just showing here the data frame. Oh, Streamlit has a very similar thing to that. It's called st.dataframe. And now I think we have our first dashboard. I'm going to try to run it, and it will give me an error. So it even says, oh, you don't need to run this Python script, you need to run it as a Streamlit dashboard. Fair enough. That's what we're trying to do. So, going to here. And now I have my nice Streamlit dashboard. Yeah, nice. It's a little bit ugly. But this is like the first version already being online. And you can just make it in a Docker container, put it somewhere on a virtual machine, and then you can have it running. And then you have your very nice model, or in this case, just a data frame showing here. Of course, doing other things is just as simple. I'm going to delete this data frame because I don't really like showing all this raw data on a dashboard. But then here, showing some figures. So in this case, I'm using Plotly Express to make the figure in the notebook. Well, we can do a very similar thing. And then one of the nice things is my dashboard, when I'm running it locally, it automatically also detects, hey, I changed something. So let's rerun it. And then I see, yes, indeed, I now have my beautiful graph here as well. Now let's actually convert the whole thing. Just to demonstrate that it really is that easy. And so one of the things you might now be noticing is what ends up happening is every time I'm refreshing this dashboard, basically the whole codes get rerun. And right now I'm just loading in some local files, but what you'll probably end up doing is reading some data from BigQuery, right, where your predictions are, or reading some data from some database or from a bucket. And then at some point it might start taking time, your dashboard might become slow. Luckily, there are a lot of caching functions in here, so it's super easy to just cache some data and say, hey, I only want to refresh it every, let's say, 10 minutes. And that, for us, it helped a lot because the data we were loading in, yeah, it wasn't that small, so it took a couple of seconds. Similar to just writing a data frame or writing some graphs, you can also do st.write. That's just showing some text. And here we have our KPIs already. So, of course, you can go all out with this. You can make nice text. It's super easy. You can just type markdown in it, put the function st.markdown around it, put the markdown in a string, and you have some nice layout as well. Quite a lot of functionality. Of course, it's not going to be like as nice as super fancy dashboarding tools. Or super fancy custom web apps. But I think that's not the point of what we're trying to do with these kind of apps. Just in 10 minutes, I already built this, or maybe even, I think he signed me, like I had 10 minutes left.
No, 5.
When I started.
Oh, you tell me you started.
Now
yeah.
I have 5 minutes left. So that means in 5 minutes, I built this dashboard. Pretty proud of myself. So let's go back to the presentation. So yeah, this is super easy to do. And I think that is the power of Streamlit or other Python-based tools you can use for this. It doesn't need to be fancy, because the user is only going to use it a lot during the first couple of weeks when you have to build up the trust. And it's just such a little investment to do this, and it can help you tremendously to gather that trust. And I think that makes it an awesome tool. So Welmoet, can you share with us what has happened when we did this at
Yeah,
Bol.com?
you can do the slide, I think, because, well, of course, we always like to have this happy end. So this is how it actually ended. We had this very happy customer. So they are still using it, looking into the graphs daily. And of course, in the first few days, they were looking at it very, very closely. Then we got a few moments that they said, oh, the system isn't working right. And then they looked into the data and said, oh, actually it is. It's just a little bit smarter than we would have done it. And I think now it only occasionally, when something really, an abnormal day is happening, that they really look into the graphs. So you see it, the use getting lower and lower, and that's because the trust is going up. And we will see what we will do in the future if we keep some of the graphs and then the software engineers can go their way, or that we don't use it. But and in the few days, I think, when we used it, we actually added some extra insights as well. So I think that's also great because you can iterate very, very fast. Just change the code and also change the dashboarding. So I think this is definitely a way we will be using now again with the next thing we're implementing. Oh yeah, and by the way, oh yeah, sorry, his controller, do you see it? It's lying on the ground because he's not using it anymore.
Yeah, thanks for sharing this wonderful ending to the story. So what did we end up learning as a team from this whole thing that has happened? Well, first of all, a model entering use apparently requires trust from the user, because otherwise they won't use it. Maybe fairly obvious, but I think it's an easy pitfall to fall into. And then getting a dashboard to show these insights, to show a little bit into how your model is working and what decisions is it making, that can really help the user to get this trust. And then you might think it's a big investment, but no, not really. Building such a dashboard can be really easy. So with that, I would like to leave you with a core call to action. Are you struggling to get your model used? Turn your notebooks into a dashboard. Thanks for your attention. I think there's now time for questions,
yes.
right?
I was just looking at them, so because we have a couple of questions, let me go up so that I can see you all. All right, thank you very much for this very interesting talk. So we do have some questions which I'm going to read out loud. So the first one is, have you run into any limitations with respect to layout and interactivity in this case?
Yeah, so I think, to be honest, we just didn't care that much about layout, right? We just wanted to show the graphs, we just wanted to show the data. So if we ran into anything, we fairly easily just said, hey, never mind, we're not going to do that. Putting some graphs next to each other is super easy. Putting some graphs in different orders or different locations, making the graphs nicer, that's also doable, of course, because you're just using some graphing library, in our case, Plotly Express. So I didn't really run into any difficulties. I think if you want to really push it further, right now you still very much at the basic Streamlit layout and the basic Streamlit theme. I think you can change these things as well, but then probably it gets a little bit more complicated. And then maybe at some point you need to also start thinking, hey, is Streamlit still the right tool to do, or am I actually trying to do some more fancy stuff that Streamlit maybe is not meant for?
All right, there's another question about how did you deploy, host this Streamlit app, and what about authentication?
Yeah, good question. So deploying a Streamlit app, it depends a bit. You have two options. On one hand, you have, I think, a managed version of Streamlit. I believe it's called Streamlit Cloud, where you can host your Streamlit application through Streamlit the company. Haven't tried that. What we ended up doing is hosting our Streamlit application on a Kubernetes cluster on GCP. Why? Because the Kubernetes cluster was already available. It was, for us, it was super easy to get it running onto. Authentication, not sure about how to do that in Streamlit. So for us, because we were running it on this GCP Kubernetes cluster, we could arrange the authentication from there. So we could only allow our specific users that we wanted to see it, could allow them to see it. But if you just want to run it, yeah, fully custom somewhere, not sure how to do the authentication.
All right, thanks. Another question is, what's the main advantage of Streamlit as compared to Dash?
Sorry?
The advantage of using Streamlit against Dash, for example.
Yeah, so personally, I don't have experience with Dash, so I really can't answer that question.
Okay,
find it difficult.
Another question is, can Streamlit dashboard can be easily automated in continuous integration?
Yes, I think so. Not sure what part of continuous integration he's getting at, because in the end, it's just a bunch of Python code. What we do, we bake it into a Docker container, and then a Docker container gets run somewhere. So that whole pipeline, you can, of course, you can do it in CI and CD as well.
Yeah, maybe doing some unit tests on the Python code of the Streamlit app.
Yeah, so what I did just right now, I made it one big script, which is of course not a nice way to do it. You can always extract these things into packages or modules, and that way you can make it definitely a lot more testable. How much you can really make the Streamlit part testable, I'm not sure, but all the data processing you can of course do that.
All right. Yeah, there are other questions related to that ones that I already mentioned. So we don't have that much time, but I do want to read one question. It's, what's a good reference to learn more about Streamlit?
Sorry, what's a good
reference? A good reference of like how to learn about Streamlit. Like, what would you recommend?
So for me, this was also a really learning experience for me, but I think the documentations of Streamlit are just really nice. They really explain everything well, and it's super easy to get started with it. So I would just start at the docs.
All right, thanks. So please, let's thank the speakers again. And yeah, thank you very much.